Okay, so type in the chat what you think the most important property or something you can say about a triangle is. Jerry thinks 3 sides. The angles add up to 180. Angles add up to 360. Oh. Okay. Yes. Okay. I think the most important of those properties, I think we all know triangle has 3 sides, but that is a very important property. It's about, yeah, Charlie, the 3 angles, and those 3 angles add up to 180 degrees. And they will be half of a square, yes. So this is just a sketch of a triangle. If we were in class on campus, we'd be able to do a nice little experiment with this, but we'll do that maybe when you're in next week. So the 3 angles, and do put this in your note, 3 angles of a triangle add to 180 degrees, not 360. 360 be a square, and if you think about that, a square has 4 90-degree angles in it, doesn't it? So that'd be 4 times 90, which is 360. So these 3 angles here add up to 180 degrees. In other words, if we cut them out, they would form a straight line. That's kind of cool in itself. We cut out those angles that form a straight line. And if we refer back to what we did already, I'll think about these 3 angles. They form a straight line, and they would also form a triangle if you rearrange them differently. Okay. So that means we can solve some problems already with triangles. If we are missing okay, so find the value of the pronumeral. So hopefully we know what a pronumeral is. If you're not too sure, does anyone know what a pronumeral is before I draw this diagram?
Is it the number that's not given to you?
Yeah, so pronumeral means numeral, kind of if you split this word up, means number, and pro means instead of. So it is the letter that is used instead of a number. So like in algebra, when we used x, that is a pronumeral. So we draw a triangle. Oops, that's not a great triangle. Do put this in your notes though. This angle here is 40 degrees. This angle here is 100 degrees. But we don't know the value of angle A here, which would be the pronumeral. Anyone think they would have the answer for the angle for A, even though we don't know what it is? Okay, so if you want to do some maths on this, we know that they all add up to 180 degrees. So it's 180 degrees is the total. And if I take away what I know, 40 minus 100 as well, take away, that will give me my answer for A. So the 180 is the total of a triangle. If I take away the angles I have, I'm left with the one I don't have. So 180 take away 40, take away 100 gives me an answer of 40 degrees. So put a little degree sign there. Hopefully you know what a degree sign is. So that's a simple example of a question. And then be kind of green level to try and find that a missing pronumeral. Let's do a second example question, maybe slightly more difficult. So this time there's going to be 2 unknowns. All right. Call that one A. This one outside the triangle, B. So now it's on screen. Sorry, I drew that a little bit off screen. Okay, so take down the question first, and then if you want to have a go at answering for either A or B, type in the chat. I'll give you a second to work on this. All right, guys. Can we use calculators for this unit for the first question? Yes, you can. Yeah, you can use calculators for every unit beyond the first one, number. Okay. So 70, 110, 70, 100. Yeah, okay. A lot of right answers there. Let's think about how we do this. I've forgotten where I've left my pen. 1 second. All right, I'm back. Okay, so first of all, we're going to use what we know already. We're going to forget about this B angle over here. We don't really care about that for the moment. We're just going to care about the A angle. We know that three angles of a triangle have to add up to 180 degrees. So 75 plus 35 take away from 180. So do 180, take away 75, and then take away 35. You can do that on your calculator if you want. So that gives me 70 degrees is A. So A equals 70 degrees. And I label my answer nice and clearly like that. Now, once I know that A is 70 degrees, that really helps me find B, doesn't it? What property will I use? I will use straight line angle or supplementary angles. These two, if I just took those out and drew a separate little sketch, A is here and B is there. So they would add up to 180. So if I know that is 70, this one has to be 110 degrees because they have to add to 180 because they make a straight line. So therefore I can just say B is equal to 110 degrees. Okay, and that'll be an example of maybe a yellow or blue level question to start off this unit. So that we're trying to problem solve. Yeah, of course, Leva. Okay. Let's do some triangle theory. Now, I'm going to use some words now that I'm sure you've heard before, but do just put them in the notes because now that we know how to solve some problems with triangles, we need to know some words and names of different types of triangles. So that's next. There's a bit of note taking today, and I apologize for that. Do make sure that's in your notes first. I'll give you about 30 seconds to finish that note off, and then you can move on to the triangle types. All right, so triangle types. Can anyone list a triangle type? You know a name of a type of triangle? Do put it in the chat there, and let's see how many of them we can come up with before I put them in the notes. So Charlie has come up with a right angle triangle. Yes, there is such thing as a right angle triangle. That's one type. Ethan and Lewis, quick off the mark with equilateral triangle. That's a good one to know. Equilateral triangle. Yes, that's another one. Any other ones? Isosceles. Yes. Some interesting, difficult word to spell, that isosceles, but a few of you come up with that. Nice, Alma. You're in there first of that one. Any other types? A scalene triangle Priyanka has as well. Yes, Priyanka. Also interesting spelling on that one, but that's okay. We're not judging the spelling today. Yes, scalene is another type. Any other type? Just those. That's it. That's it. Okay, well, let's see if you're right. The first one we're going to look at is a equilateral triangle. The perfect triangle, if you will. Equilateral triangle. Each angle Priyanka has it is 60 degrees. That's because it's perfect. Each side is the same length. So if we were to draw it perfectly, each side would have to be exactly the same length. Each angle exactly the same side. So how do we show that sides are the same length? We use these lines to indicate that they are the same. And we can do that with the angles as well. We know that they are, you put a line like that and it indicates that it is the same size. So the properties then, I'm just going to put here on the right. Each angle is 60 degrees. And each side is exactly the same length. And that's an equilateral triangle. I'm sure you've heard that word before. So that's very useful. So all these angles are 60 because if you think about it, 180 degrees divided by 60 or divided by 3 is 60 because there's 3 angles there. That's our first type of triangle. Our second type of triangle then is going to be an isosceles triangle. What's special about this one? Does anyone know?
All the sides are different.
Not quite, Priyanka.
Is it that 2 sides are the same, but only one shorter and longer one?
Yeah, you're getting there, Lauren. So 2 sides would be the same. Anything about the angles? No, Charlie, it's not all angles are different.
2 are the same as well?
2 are the same. The 2 underneath the same size. So if we have, yeah, you were thinking of, so if we have 2 lengths that are the same, so let's make this a little bit longer, and this is shorter. So these 2 lines are the same length, so we can mark those the same length, but this one's different. This one's different. The 2 angles underneath, so the 2 angles here, are the same. This and this. This one at the top is not the same. It's narrower. So isosceles triangle then has 2 sides. So the first one had all 3. This one has 2 sides, the same, and 2 angles, the same. Okay, the same is not a very mathematical term, but we'll go with it. The 2 angles, and make sure you indicate as 2 angles underneath the sides that are the same, not this angle where they meet. Helicopter flying overhead here. All right, so what's next then? If we've 3 sides the same length here, 2 sides the same length here, I think the next logical step is to do when none of the sides are the same length or they're all different. Perhaps, Charlie, the next logical step may have been a right angle, but I'm going to go scalene next, and this is the correct spelling of scalene. Scalene triangle next. And that is when we got a triangle that has all different sides and all different angles. So nothing the same. All sides, and this is the one that probably occurs most often. If you just draw any old triangle, you're going to end up probably with a scalene triangle. All sides and angles are different. And that's a scalene triangle. So do make sure to have good notes taken. We'll move on to Charlie's one next, the right angle triangle. So that's just any old triangle that includes a right angle. And those of you guys that thought about Pythagoras' theorem for our pool challenge, there was a right angle triangle in the pool challenge, and you can use something called Pythagoras' theorem for that, but you don't do that until next year. But it is using right angle triangles, and right angle triangles are very important in mathematics. This is where we start off with them. So a right angle triangle is a triangle that has a right angle in it. Not exactly rocket science, this one. So a triangle that has a right angle is a right angle triangle. Look at that. Okay, any other types of triangles? I think this is all the ones that you guys came up with. There are two other types, probably not as important. There's something called an acute angle triangle and an obtuse angle triangle. Now, the acute angle triangle is when all angles in the triangle are less than 90 degrees. So it's a bit like, you can draw it a bit like a scalene. So you can see that all angles here, none of these are quite 90 degrees, and that's all angles are acute. So less than 90 degrees. In other words, less than 90 degrees. So we can put in that less than symbol there. Yeah, someone's been doing some research there, Ethan. Yeah, you can go on forever. You can have different types of right angles. Yeah, you can have right angle isosceles and so on, and right angle scalene. But we'll just stick with a right angle triangle for the moment. Yeah, but that's true. That is true, Ethan. Yeah. An obtuse angle triangle is a triangle that has an obtuse angle. So let's make an obtuse angle first. That's definitely an obtuse angle here, isn't it? Okay, and if I just join those together, you can see that that is an obtuse angle. So obtuse angle triangle, one angle is obtuse. Can anyone tell me the reason why you can't have more than one obtuse angle in a triangle? You won't make a triangle. Very good. Yeah, I'll draw a sketch on the other side. I don't think it'll be a square, Charlie, because a square is exactly 90 degrees each angle. I will wait, Charlie. You tell me what to do next. Just be deformed. But will it be deformed triangle? No, kinda. Well, we'll try it in a second. Yeah, pentagon can have two obtuse angles. Yeah, pentagon can have all obtuse angles as well. Okay, so that's all the notes we need for today. But I will just talk about a doubled obtuse angle, can we make a triangle out of that on the next slide? So I expect this to be nice and neatly taken in your notes. If you need a new maths book, I've put a couple of them at the top gate with security at the top gate up by Finn's car park. If you want, you can pop in and grab one. And if you specifically want your own maths book back, I can put it up there tomorrow for you guys as well. Just let me know, drop me an email. I'll try and do that. If not, well, hopefully we'll be back on campus real soon. So yeah, it's only if you run out. Okay. All right. So let's just talk about those two obtuse angles. So let's form the smallest obtuse angle. So if we just go 91 degrees. So 91 degrees is the first obtuse angle. So if I need to put another obtuse angle in that, let's put, where do I put it? Well, if I try and add another 91 degree angle to a triangle, the first thing I notice is that that's 182 degrees, and I've only used up 2 angles, and that's too much. And even if I drew, I need this to come back down. I need it to be acute to form a triangle, don't I? If I draw an acute angle off there, or an obtuse angle, it's gone off on its merry way, and these 2 lines will never meet to form a triangle. So that's the reason why we cannot have 2 obtuse angles in a triangle. All right, I haven't done attendance yet, so just get ready to turn on your microphone and let me know you are here. No, you don't need to take what's on the page down. No, we finished the notes at your